Peace in YouTube. How is everybody doing? This is Greg from GregsTutoringNYC. Hopefully everybody's doing good out there. So I'm doing this new series about the hardest math problems. I did the first part already, which is grade 3. We're going to do grade 4 today. So let me just kind of go through it a little bit again. We're trying to look at what I'm defining as the hardest math problems. I'm basing these problems off of the New York State math tests. So that's just one way to approach this and one perspective of it. Not the only way to define what a hard math problem is, but traditionally the state tests are following the Common Core standard, which is what New York has, plus some additions on top of it. Most states, whether they follow the Common Core or not, are basically tweaking different topics past that. So if there's 1,000 topics from grade 3 to grade 8, divided by 6 or 7, depending on how many years we're going to look at. There's a couple hundred topics per year to look at, and the questions on the state test are about some of those topics in the standard and so on. And we're going to approach it that way. So what I did was I did a survey of all the past state tests in New York and found the ones that kids got wrong the most. So that's how I'm defining hard. Now, in some cases, the hardness was in the wording and not necessarily in the raw math. On the same note, math is about interpretation and understanding and things like that. So we need to figure out about terminology, English phrasing, mapping math to English, mapping English to math, and stuff like that. So even though this is based on New York State test, I don't want to hold it to New York State. It should really be true of any fourth grader in the case of this video. Realizing that some standards and some districts and some states, however we look at this, might have one topic in one grade, another topic in another grade. I'd rather this not be grade oriented, but we have to look at this in some kind of linear progression. So why not pick something that's a common known perspective and common known target? I do a lot of teaching for standardized tests. There's a lot of debate about whether they're useful or not. There's a lot of aspects of standardized tests that are not useful, but there are some that are. There is some level where it is a test. There's some level where it is testing your knowledge. Okay, I would like to go a little deeper than the raw knowledge, because as much as we need to memorize and do things rotely and follow instructions, really at the end of the day, I want to approach this as problem solving. Okay, and looking at concepts and looking at topics and looking at techniques, and we're going to kind of delve into some examples about your numeric mastery and your numeric fluidity and just generally speaking your numeracy. Okay, so that's really what the goal of these are, is those things. So it's not so much we're looking at the hardest problems, but they're the ones that kids are goofing up the most. So for whatever reason that may be, we're going to explore some of these problems a little more in depth, okay? And so with that in mind, let's just jump in here. So let me get rid of this screen here. And if you guys need to email me, my email is floating across the bottom there. I'm GregsTutoringNYC@gmail.com. I've been tutoring for a few decades. I mainly tutor on standardized tests for high school admissions, but I also tutor for high school, middle school admissions, and all grades admissions. Like I tutor for the ISEE and the SSAT. So I also tutor for the SAT and the PSAT, and all sorts of oriented things like that. But I also do homework help. The majority of my tutoring is in math and English, but I also do for science. I can do projects. I'm a computer programmer by trade, so I can help in programming and things like that as well. And I found that through all the disciplines and careers that I've been involved with in my life, that thinking about problem solving and how to approach a problem is one of the most important things. So that's really what I want anybody viewing this to get out of this. We can talk, for instance, problem number 33 is on the screen right now. We can talk forever about how to solve that. But I don't want to solve problem 33 and then 34 and then 35. I want to present to you guys problem-solving techniques and how to think critically about things and how to do mapping and just try to understand the world as it is, right? Math is modeling the world. So when we're given quote problems, we need to be able to do and address something like that. All right, so let me load the screen here. So we're going to jump to problem question number 33 here. Which statement best classifies the figure below? So this is math, and this is the state test, and they're giving you 4 choices over here. So this notion of bestness is a weird one, because they're only looking for one answer here, and a multiple choice test, if it's written properly and has been vetted, which means they've run it through different ways to approach it and ask the question, there's only one answer. So we can almost ignore this word, because which statement classifies the figure below. Okay, that's really what we're looking for here. These are kind of distractor words. Now there's some examples, usually in the ELA section of a test like this, where words like that might come into play, but they're normally still distractor words. It is nice that they told us that word, and it's nice that they bold-faced it. But the ugly part of standardized testing is we can ignore that in a lot of cases. Just keep that in the back of your mind, right? So we can talk about test taking skills as well, in addition to the math, in addition to your mastery, okay? So what statement classifies the figure below? So what I like to do is I like to just look at a figure before I even look at the question. What is this, right? It's a closed figure. It's a polygon. And there's how many sides to it? There's 1 side, 2 sides, 3 sides, 4 sides, 5 sides, 6 sides, 7 sides, 8 sides. So there's an 8-sided figure. It's talking about classification. So I'm going to think already octagon, right? It has 8 sides, octagon. I don't know what they're going to ask me in the question yet. I haven't looked at it. But that's what I'm thinking. Oh, there's an octagon here that's closed. They don't give us too much other information in here. It looks like it's a regular octagon. When a shape is regular, it means the length of the sides and the length of the angles are going to be the same. So I just labeled the 8 sides with a number. It would mean the length from here to here is the same, for instance, as the length from here to here. When you have a regular one, also means this angle here is the same as that angle, 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 that angle. Okay? So when it's a regular polygon, like a regular trapezoid, right? We can create a trapezoid like this. Normally it looks something like that. Okay, I'm doing this freehand. But a trapezoid can also look like this. Okay? And we can even take the octagon that's here now, and I'm going to draw this freehand, so and I'm going to change the color here for a second. If I fill in the next 2 sides here, okay, if I was to take my finger and push that in, okay, now we're going to go back to the green. If I push it into something like this, so this side's going to go away because it's this side, and this side here is going to go away because it's that side. It turns out this figure here, if I was to shade it in, that's also an octagon. It's an irregular octagon, okay? So these are both octagons. This one, this angle, and this angle, and this angle, and this angle might be the same. However, this angle and this one here and this one here are not going to be the same, right? So that's what I'm talking about. This. So this is called an irregular octagon. This is a regular octagon, okay? So let's finally actually get to the question. So it tells us the figure has opposite sides that are perpendicular. So if this is the side right here, then an opposite side is the one straight across from it, okay, which is here, okay? So it says they're perpendicular. Opposite is perpendicular. Is these two blue lines perpendicular? A perpendicular line meets at a 90-degree angle. So that would be 90, and that would be 90. Okay, that's not what's happening in the figure. So this is false. Okay, B, the same thing is perpendicular, that's false. Okay, C, the figure has opposite sides that are parallel. Yes, that is what's going on here. Okay, and a measure of 135. Ooh, how do we know that? We don't have a protractor, right? At least in the New York State test and this kind of test, you're not given a protractor. Okay, so can we figure that out? Okay, and then D says the figure is opposite sides that are parallel. So C and D has a measure of 45. Okay, well, if we look at the angles here, this angle here, right, if it's greater than 90, there's 90, right? If it was less than 90, it's going to look like that. It'll be acute, right? And if it's greater than 90, it's going to look like something like that, which is obtuse, right? So all the angles in this regular one are obtuse, which means they're all greater than 90. Therefore, the answer must be C. And these numbers here, the 135 and the 45, it's not like this was 89 and this one was 91. In that case, it becomes really hard to figure this out, okay? But since this is so far away from 90, and this is so far away from 90 as well, we know that the 135 is the obtuse angle that they're looking for without even needing to calculate it, okay? So we used, this is a geometry-based question. We used all the facts we knew about stuff. So this covered a lot of topics, okay? It covered shapes, what kind of shape it is. It covered opposite sides, because there's other sides like adjacent sides. If I was to put this right here, that's, whoops, that's adjacent there. Okay, forget that squiggly line coming out there. My tablet pen is, I keep pressing the button accidentally. So these two lines here, the blue line and the red line here, they're adjacent to each other. So we learned terminology, opposite. It went through perpendicular versus parallel. And we also had things about angles. We had to use our knowledge and our identities that we know about stuff like that, right? Okay. Just as kind of a little sidebar, there is a way, there is an algorithm to compute the degrees of an angle in a polygon, a closed polygon. Okay. And I'm going to write it down here. That's n minus 2 times 180 over n. So that's n minus 2 in parentheses times 180 over n. So n is the number of angles. So there was 8, we showed earlier there was 8 lines making the shade up. There's also 8 angles inside of here. So we're going to have 8 minus 2 times 180 over 8. Now my tablet's messing up here. I don't know why. What's going on, tablet? And that's going to give us 6, right? 8 minus 2 times 180 over 8. Okay? So if we simplify that, I'm going to write that again over here. So we end up with 6/8 times 180, basically. Okay? This becomes 3/4. So we have 3/4 times 180. Okay? And 4 can go into 180. And I showed yesterday how we can divide something before we have it. So 180 divided by 2 is 90. And 90 divided by 2 is 45. So this turns out to be 3 times 45. And that's 135 when you multiply it out. Okay, and that turned out to be what C was talking about here. So we have a way to double check this through various techniques, including actually calculating it. Now, if this is actually a standardized test, normally you have a time limit, and even if it's untimed, so actually doing this formula, this n minus 2 times 180 over n, could take you a bit of time, because it's a whole bunch of extra calculations that you have to do. All right, so be careful with that. Multiplying by something by 180 can kind of get nasty and ugly. We got lucky that this was able to, over here, cancel out and become 3/4. And we were also lucky that 4 divided into 180 fairly easily. All right. And if you can't do 45 times 3 in your head, you can always go on the side and do it. Right. Your 5 times 3 is 15. Carry your 1. Right. 4 times 3 is 12 plus the 1. So you're going to get 135. Okay. So you still got that same answer either way. All right. So there's a lot on the screen right now. By the way, if you guys need to email me about any question I'm going over here, please just identify it and say what grade I was doing this with. We're going to do a whole bunch of these, and there's going to be a myriad of problems and so on. Also, by the way, as I come to a new problem, you could try to solve it yourself. Pause the video. For those of you who are on here live, that's cool. At the moment, I'm not doing grade 3 and grade 4 live. I'm actually doing this at 2 o'clock in the morning. So, but probably grade 8 and grade 7 and grade 6, and maybe grade 5, I'm going to actually do live with kids during the daytime, students during the daytimes, I should say. So anyway, you should pause the video, and even if you're going live, you can still pause the video and then catch up to it. But if you're live, you can kind of interact with me then. All right. So that's that question. So you can see there was a lot going on with that previous question. So there's a lot of reasons why a kid may or may not have gotten that problem wrong. Let me just make sure we're still live. So even though we're doing this at 2 o'clock in the morning, I want to make sure that it's still going reasonable. Yes, it seems to be. Let me just do one thing too, just to make sure I'm live and that my audio is coming through. I'm going to just check this out on my phone to make sure we're going okay. Actually, it's not letting me do that. All right, I'll worry about that later. Okay. YouTube sometimes messes up, but we see them live. So let me go back to this. So the price of the board game is $24. Okay. So we're always trying to note what they give us. A board game is $24. The price of a board game is 2 times as much as the price of a jigsaw puzzle. Okay. What is the price of the jigsaw puzzle? So let's take this again a sentence at a time. Okay. So the price of a board game, the board game is 24. Okay. Is normally means equals in math. Okay. The price of the board game is 2 times, because now they're also telling us something else. The price of the board game is $24, and then they repeat the price of the board game is. Okay. So the price of the board game also is equal to 2 times the jigsaw puzzle. Okay? So this is what the error that some kids make, which is why I think most kids got this question wrong. Then it asks, not what is the price of the board game? We already know it's 24. What is the price of the jigsaw puzzle? Right? What is the price of the jigsaw puzzle? If the second equation here is true, okay, it means that the board game divided by 2 is equal to the price of the jigsaw puzzle. Okay? Reread the English and convince yourself that that's the case. Right? We can use numbers. If the jigsaw puzzle was $2, then the board game is 4. If the jigsaw puzzle was $10, right? Then the board game is 20. Right? So it also means that if we use the formula over here now, that if the board game was 20, then the jigsaw puzzle is 10. And if we use this again here, if the board game was 4, then 4 divided by 2 is 2, which is what that was. All right? So don't let the English screw you up here. I think most of you know your multiplication table, certainly like the 2 times table, and when something's talking about having, okay? But the basic deal is if this equation here is true, we have 2 equations, A and B. Okay? If B is true, then you have to see that the price of the jigsaw puzzle is half of the board game price. The board game's twice as much as the jigsaw puzzle, then the jigsaw puzzle is half the price of the board game. Okay? And we already know the board game was $24. Therefore, the price of the jigsaw puzzle is 12. Okay? So this is kind of a logic problem, even though this inside of here is algebra. Okay? At grade 4, you're not really formally taught algebra in the United States, and certainly not in New York City. That's normally formally done in grade 7, and then even after that in grade 8 and grade 9. You learn algebra through all your school years, but to get super deep into it is a different situation, all right? So what you need to do is think through the questions you're being given and ripping it apart a sentence at a time. Read up to here, make sense of it. Read up to here, make sense of it. And then finally answer the question, okay? Okay, so this also turns out to be algebra, where we have something plus x equals something else. In this case, the question mark is the x, okay? So the fact that these are mixed fractions, mixed numbers, right? If this is a mixed number and this is a mixed number, shouldn't interfere with us. Because if I had 5 plus question mark equals 7, right? Many of you know that this is 2. That's 5 plus 2 is 7, right? So we're going to do the same thing here. And the kind of formal way to do this is to do 7 minus 5 and then get 2. So if we model that, when we take something confusing like what we have here, okay, just look at it as more simpler numbers, figure out what the procedure should be. Okay, it's not fail-safe, not a guarantee, but if once you figure it out and use kind of simpler, more sane numbers, then that's the way you're going to end up working it, okay? So basically what we're having, if we follow that model, is we have 7 1/8 minus 3 2/8. Okay, so again, as I'm doing all these problems, there's always multiple ways to do these, okay? So what we need to do, we're going to do is we're going to subtract 1/8 from 2/8. So you can't do that. You can't take it away. So what we're going to do is rewrite this. We're going to borrow a whole number from this. So we're going to have 6, right? And if I have 8/8, okay, because 8/8 is the same as 1. Any number over itself is 1, okay? So 6 plus 1 is still the 7, okay? And then 1/8. And we basically going to add the 3 of these. That's going to give us 6 and 9/8. So this is the same as borrowing that you do in other cases. So we're going to still keep the minus 3 and 2/8. Okay, so now we have 9/8 minus 2/8 is 7/8. And 6 minus 3 is 3. Okay, and that just gives us 2. That's B, I should say rather. And we can always take the answers here and add them. So if you take your answer, 3 and 7/8 plus 3 and 2/8, we're going to get 6 and 9/8. Okay, 9/8 is the same as 1 and 1/8. So that gives us 6 plus 1 and 1/8, which is 7 and 1/8, and that's our original number here. So we have a way to double check this as well, all right? Okay, there is other ways to solve this problem. So let me rewrite the question again, or you know what? Let me erase this so we have a place to show the alternate. I prefer the way I showed it to you already, but I'm just trying to give options for everybody thinks different, and different schools and different states are taught different ways. So it's kind of something you should know in anyway. What we can do is we can count up. If we're at 3 and 2/8 here, how do I get to 4? Okay, to get to 4, I have to add 6/8, right? 3 and 2/8 plus 6/8 gives me 3 and 8/8, or 4. Okay, so now what we need to do is we're at 4, so we're going to go 5, 6, 7. So we're going to add 3 into there. Okay, and then we have to get the extra 8th. So we're going to add an 8th again. Okay, so we have a 6/8, 3, and an 8th. Well, that's equal to 3 and 7/8. And that's the answer again. So all we did was we started at the first number and we kind of counted up. So we got to this number. Okay? So if you notice, that was less messy, but it's kind of a more naive way to approach it. On the flip side, they're not asking you to show your work in this example. They're just asking you to circle on a bubble sheet what the right answer is. So this is another alternate way to express your solution to show that you got the right answer or not. Okay? So it's an interesting approach. And if you notice, it took a little shorter time. And by the way, even though they showed us an equation here, right here, this could have been a word problem. It could have said a plant started out at 3 2/8 inches. Over the summer, it grew. And at the end of the summer, it was 7 1/8 inches. How many extra inches did it grow? And then yet again, end up doing the same thing. So from that words, you would end up writing this equation here and then still having to solve it, right? So there's different ways they can tweak these problems and different ways they can show them to you. All right, so let's try the next one. Okay, so we're going to take this. We're going to look at the figure first. I'm not going to look at the words. So there's some sort of rectangle, and it looks like 2/3 of the rectangle is shaded in, right? There's 3 parts, 1, 2, 3. Again, I'm not even looking at the question. I have no idea what the question is. Okay, and it looks like 2, A and B here are shaded in, and this part isn't. Okay, not shaded. All right, so it looks like thirds. We don't know where they're going here. There's nothing else really here except that we can identify as a rectangle, and 2/3 of it looks shaded in. Okay, so let's see what's going on here. Jason makes aprons. Okay, I always put this little kind of thing here. There's not really much they're telling us there. The shaded part below, where below? Right here. This and this. Okay, represents the fraction of a yard of fabric he uses for each apron. What does that mean? The shaded part below represents the fraction of a yard of fabric that he uses for each apron. Okay? Well, it looks like he's using 2/3 of a yard. Okay, we don't know if unit conversions are going to come into play here yet. So let's keep that in the back of our mind that we may have to worry about the units at some point. Because sometimes in these questions, they end up talking about feet or inches or whatever, or vice versa. They start off by talking about feet and they end up asking about yards. Okay? So I think we interpreted the second thing right. We interpreted the figure already. Then they ask how many yards. So the unit's still there. In all, will Jason need to make 14 aprons? What's going on here? Right? He needs 14 aprons. Okay, so let's go look at the problem again. Jason makes aprons. The shaded part below represents the fraction of a yard of fabric he uses for each apron. So this is worded kind of in a strange way. So he needs 14 aprons, right? And each is going to use 2/3 of a yard. And that's it. So we have 14 times 2 is 28. Over 3. We have a fraction. It's top heavy. It's top heavy because the numerator is larger than the denominator. So let's write that as a mixed number. We have 3 is still the denominator. 3 times what is going to bring us close to 28. So now we need to know our multiplication table here. So that's going to be 9 times 3 is 27, plus 1 more is 28. So that's our answer there, 9 1/3. Okay, and we get B here. All right, so again, we have the total number of aprons times the size of each apron gives the total number of apron fabric that we need. Okay, I believe some kids misinterpret this problem as implying that they're going to throw this part away on each apron. So in other words, a lot of kids might think they need 14 of this whole thing here and then just throw that away, okay? But the problem is no answer matches that. So some kids might say the answer is D, but it's not, okay? So it can be confusing, okay? And some kids are going to say A because A is the same as 14/3. But it's not 14/3, it's 14 times 2/3. 14/3 is the same as 14 times 1/3. So it's definitely not that, okay? And this is equal to 40/3. I don't even know where that comes from. So that may have been just the nonsense answer that they threw in the middle of this. All right, so be careful with some of these. Again, these are problems that most kids got wrong. Okay, this doesn't quite fit on the screen, so we're gonna just take it a piece at a time. So it says, which set of models is equivalent to the expression 2 times 4/6? And each choice gives a whole bunch of different boxes. Now, just to be clear how they delineated this. Okay, so that's our A, B, and C, D in there. When you first look at it, it's just like, what is possibly going on here? There's a thing, what sixth is here, and this is shaded in here. So this box is actually 1/6. This box is a 6. This box is a 6. This box is a 6. That's a 6. And we have 8 of them, right? So we have 8 boxes with each with the 6th on it. How does that help us? I don't know. A little confusing. Okay. B has 2 out of 4, or it's the same as a half. Okay. Right. And it has 6 of those. So that's basically 6 times a half then. And that's equal to 3, by the way. Right. And by the way, 8 times the 6th up here is equal to 8/6. And this is really confusing. But if we look at this, this is a whole number, this is a whole number. So this is 2, right? 1, 2, 3, 4, and 4/6, which is equal to 2. 4/6 reduces to 2/3. Okay, and then what we have under here is really busy. It's even worse than A was. So each of these has 1, 2, 3, 4, 5. It has what, 12? 1, 2, 3, 4 times 3 is 12. So each of these is a 12th with one shaded in per, and there's 8 of those. Okay, and if we multiply that out, we get 8/12. And if we reduce that, we get, what, divided by 4, we get 2/3. Whoops, I read 4/3, 2/3. Okay, so if we go back to the original problem, what exactly are they asking us? Okay, which of these is equivalent to that? Well, if we actually multiply this out, instead of the question mark, we put equal sign here, we get 4 times 10 was 8, and that's over 6. That turns out to be what A was, right? That's what we wrote here. It's 8/6, right? Each of these is a sixth, and there's an eighth. That's what it's asking here. It's just a different form, okay? It looks like it's not the case. There's 2 rows here, right? And it's 1/6 out of each. But if we add them up, we get 1, 2, 3, 4 out of 6, right? So it does turn out that's the way we can do this partially visually as well, okay? But the simplest way to do this is multiply this out, get the 8/6, and match that to the 8/6. Of course, they're both equal to 4/3. But that's a side issue actually to this problem, okay? And we can see that none of the others matched it, okay? All right, so we have 11. We're going to look at the diagram first again. So they're showing us a square, and they're showing us that the length of the side is 4, and we know that it's, well, actually, we don't know it's a, if we only look at the figure, we don't know it's a square yet, but it looks like one. And we're told that the length of at least one side is 4. So there's nothing else they're giving us there. We don't know if they're asking for the perimeter, they're going to ask us for the area, they're going to do it, I don't know what, okay? So now we're going to go back to the words, and it's going to say a square is shown below, okay? So that means that this here is also 4, okay? And without looking at the question, and this may be kind of testing you guys too, the area here, right? The area of a square is equal to the side times the side. And that's normally spoken of as the side squared. Okay, so in this case, it would be 4 squared. And that's equal to 16. Okay, that's the area. If we were looking for the perimeter of the square, right, it'll be 4 times the side, because it's this side, plus this side, plus this side, plus this side. Okay, so in this case, it's 4 times 4. Okay, and that's also equal to 16. So it turns out in this example, the area and the perimeter are the same. Okay, we don't know if that's what they're asking us, and I'm not saying for you guys unless they do this. I was adding on additional concerns to the problem. Now, when you get a problem like this, and it's going to say something like that, it's almost always going to ask you about the area or the perimeter. It may ask you other stuff too. Okay, but that's kind of a heads up that you should be looking at that kind of a thing. So now let's look at the words. We're going to take it a sentence at a time. Kelly drew a rectangle with the same area as the square. Okay, so there's another shape being drawn. Okay, Kelly drew a rectangle with the same area as the square. We already said that the area of the square was 16. So the area of this rectangle is also 16. Okay, so there's a lot, turns out that there's a lot going on in this problem already. Okay, we don't need this. And like I said, I only did this for your purposes to kind of give you a little inspiration, but it turns out that we needed to do this anyway, because it's asking us that, okay? So now it's telling us the length of the rectangle is 8. So traditionally, we take the longer side, then we call that the length. And they're telling us that's 8, okay? And the shorter side of a rectangle is normally considered as the width. So now they're asking us, what is the perimeter of the rectangle. Okay? Well, the area of a rectangle, they're telling us it's 16, and they're telling us the length of the side is 8. So we have to kind of go backwards in some of that. So the area of a rectangle is normally length times width. So in this case, we know the area of the rectangle is 16 equals the length is 8 times W. So therefore, W is equal to 2, right? So that means this is also the width. That's 2. Okay? And now we have everything we need to get the perimeter, because this is going to be 8 as well, and that's going to be 2. So there's a couple of ways to get the perimeter, but at the end of the day, we just add up all the sides. So 2 plus 8 here is 10, and this 2 plus 8 is 10, so the answer would be 20, which is C. Okay? So that was not too bad of a problem, but there was a lot of steps to it. Even without this part here, there's still about 5 steps there. And again, this is now dealing with geometry, it's dealing with area, it's dealing with perimeter. Our units again stayed the same. It was always inches, right? That's inches there, and this was inches here. Be careful with that as you're doing these problems. We're getting lucky so far that they are all the same units, but it's not necessarily going to be the case in every case. Okay, we have a different kind of a problem now that's being expressed in a different way. Okay, so some bakers make apple pies. So what we're going to do is add on, like we did before with the thing. We have a bunch of sentences here. There's no illustration. Some makers bake apple pies. Cool, line. They have 15 boxes of apples. Cool. Each box has 18 apples. Cool. They use 7 apples per pie. Cool. What is the total number of apple pies that the baker can make? Okay, so what you kind of have to do here is piecemeal a bunch of stuff together. So there's 15 boxes of apples. Okay, each box has 18 apples. So 15 times 18 is the total number of apples. The total apples equals 15 times 18. Okay? They use 7 apples per pie. So what is the total number of pies? Well, it's going to be the total number of apples divided by the number of apples per pie. In this case, it's 7. Okay? And that's what we need to solve there. So there's kind of a nasty multiplication here that you have to do. It turns out that 7 does not divide into 15 or 18. So you actually have to do this nasty multiplication. So let's do 15 times 18. Okay, we get 8 times 5 is 40. 0, 4, right? 8 times 1 is 8, plus 4 is 12. 1 times 5 is 5. Okay, 1 times 1 is 1. So it looks like we get 270. It's the total number of apples. Okay, now we have to take that 270 and divide it by 7. So 7 goes into 270. Seven goes into 2, we can't do it, right? 7 goes into 27 3 times. That's 21 with 6 left over. Okay. 7 goes into 60 8 times. Because 7 times 8 is 56, right? And we have 4 7s left over. Okay. So that means this last pi we can't make. So the total number of full pies, there's an implicit word there. Full pies is 38, or B. Okay? And by the way, when you're doing your double-digit multiplication, there's a way, if you flip the numbers, you have a way to double-check that by flipping the numbers. Whoops, let me write that again over here. So if we do 18 times 15, okay, we can just compute the numbers in that same kind of a way. So 8 times 5 is 40, 0, 4. 5 times 1 is 5 plus 4 is 9, right? And then we're going to do 8 and 1 for 1 times 8, 1 times 1. And we get 0, 9, 8 is 17, 7, 1. So we get 270 for that, okay? And that confirms the number we got over here before. All right? So you have ways to double check your calculations by just doing them different ways, okay? It turns out there's really no other way to double check this kind of calculation. And it just comes down that this is just mapping the words into doing a multiplication and a division problem, all right? Pseudo annoying, but that's the way it goes. Okay, so we haven't seen this one. And the grade 3 one, the number line came up often. So this is the first time a number line is coming up. So we're going to look at the illustration first. There's a couple of things happening. We have the 0, we have the 1, and we have the 2, okay? Within each, we have 1, 2, 3. So that implies this is a third. This is 2/3. And this is also split into 1, 2, 3. All right? So this is 1 1/3. This is 1 2/3. Okay, and this is 2. And of course that was a 0. I put tick marks originally here, but so we have 0, 1/3, 2/3, 1, 1 1/3, 1 2/3, and then 2. Okay? So then it's going to ask us which number on the number line below represents 4/6. Okay? Well, 4/6 is the same as 2/3. Okay? And we already said that B was 2/3. All right? So the answer to that would be that. Okay, 4/6 here, because we had thirds, and there, that doesn't mean we look from here to here saying, oh, that whole thing is 6, because 3 plus 3 is 6. And then we don't go 1, 2, 3, 4, and say the answer is C. That's not the way to do this problem. Okay, so be careful with that, right? There was the 0 here, the 1 here, and the 2 here. So you have to be careful with that, all right? And a lot of kids got this question wrong. So be super duper careful. The 1 is here. That was the 1 right there. So 4/6 is less than 1. So the answer can't be over here. It just can't be. Okay? And this was the 0. So the answer has to be within here. Okay? So Becky and James have a total of 4 2/8 feet of yarn. Becky has 1 5/8 feet of yarn. How many feet of yarn does James have? So the total is 4 2/8. Okay, Becky has 1 5/8. Okay, and all we're going to do is subtract both these again. Okay, we have 5/8 and above that to 2/8, so we're going to borrow again. So we're going to get 3. And since we took 1 away from the 4, we're going to get 8/8, right? So we get 3 and 10/8. So this is similar to what we did earlier. I forget the problem number, but you can go back to that. And this is still 1 5/8. So 10/8 minus 5/8 is 5/8. And we converted the 4 to a 3, and 3 minus 1 is 2. Okay, that gives us 2 5/8, which is choice number A. Okay. We could have also done this the way we did the earlier problem. If we're going to go from 1 5/8 to 4 2/8, we can count up. So to get from 1 5/8 to 2, we're going to go 3/8 up. Okay, and then we're going to go from 2 to 3 to 4. Okay, so we're going to get rid of that, and that's 2. Okay, and then when we're at 4, we still have to go 2 more 8s. And if we add 3/8 plus 2 plus 2/8, we get 2 5/8, which again is A. All right, so you have a way to double check this. Okay, you can also take the remaining answer again, the 2 5/8. Add it to the 1 5/8. And that gives us 3 and 10/8. Okay, 10/8 is equal to 1 and 2/8. And we need to add it to the 3, which gives us 4 and 2/8, which just brings us back to the original number. So there's lots of ways to double check what you're doing here to figure out what some of these things are. Okay, we only have a few more problems left here. Okay, so this problem kind of turns out to be easy, and I think it's the words that just blows kids' minds. So Miss Larson is going to buy 2 delivery vans. Okay, the price of the first one is here, is equal to that. Okay. Okay, so in a way, the 16257 is our illustration. All right. So he's buying 2 delivery vans. Cool. The price of the first one is shown below. Cool. And it's 16257. It says the digit 2 in the price of the second van is 10 times the value of the digit 2 in the price of the first van. Huh? Right? Which amount could be the price of the second van? So this was the first price one. Something here is the price of the second van. Okay? Right? Does that make sense to you guys? If not, just give it a second and read it through. Okay, and this sentence here is the killer sentence. So it says the digit 2 in the price of the second van is 10 times the value of the digit 2 and the price of the first van. So here's the digit 2 and the first van price. Okay, so if you guys remember, you were taught place value, right? That 2 is in the hundredths column. Okay, so that means the value of the digit 2 here is 200. That's what that means. That's coded language for 200. So it says, if we go back to this arrowed line here, the digit 2 and the price of the second van is 10 times that value. So that means the value of the digit 2 in the answer has to be 2,000. So which of those numbers has a place value of 2,000? It looks like A to me. B, no, that's a 10. Okay, this is 100, and that's a 10,000. So the only one that has it would be A. Okay, because that's 12,000. That 2 is in the thousandths column, which means the value of the 2 is 2,000. Okay, and that's the end of that question. And this question comes up often, at least in the New York State test. It comes up often enough in different shapes and forms, but normally it's as straightforward as this, and it's really just a place value question. It's worded tricky. Once you see it, you just stick it in the back of your mind, and you should be able to get these problems. But again, it's about your mastery of math. So that's the kind of thing you want to get at here. So this is a geometry problem now that's written as a word problem. Let me just see if there's a question up there. No, it's not. So Mr. Fuller wants to put fencing around his rectangular shaped yard. So once we see something like that, we're going to stop there. Okay, let's draw. You don't do all this in your head. Always draw and write out your math problems. Okay, the width of the yard is 55 feet. So traditionally we use the shorter side. 55 feet is the width, and the length is 75 feet. And traditionally that's the longer side. Okay, so how many feet of fencing does Mr. Fuller need? Well, I just wrote two sides, we need to get these two sides as well. Well, this is going to be 55 as well, because it's a rectangle, and this is going to be 75 feet. Okay, and everything's in feet. That's in feet, and that's in feet, and all the numbers I wrote round here are also in feet. So it's asking how many feet of fencing does it need? So this is a perimeter problem. This is a perimeter question. Well, what we need to do is add up 55, 75, 55, and 75, depending on how you want to do it. We can add these two together and get 130. So then we would end up with 260 that way, right? We could also add 75 and 75 here and get 150, and then add the 55 and the 55, which is 110. So 150 plus 110 is 260, right? So this is a standard question as well. And again, they're asking, this is a perimeter problem. How much fencing around only, right? Perimeter just deals in linear feet. Okay, this is not an area question. They're not asking for the area of the thing, which would be probably choice C or D. I don't know which would have to do the multiplication to see. Okay, they're only asking us how much would the border around it be. That's where you'd normally put a fence, right? Not an area question. Give me a second to get to the last page. We either have one or two more questions left, depending on how many's on that last page. I don't know yet. Yeah, actually, I can get through it right away. So there we go. Whoops. Where'd it go? Okay, what is the measure in degrees of an angle that is equivalent to 1/360th of a circle? So this is a geometry question dealing with your some of the facts of your circles. So if we were to draw a circle, okay, let's say that's the center. That might be a radius. This might be a diameter. That's the circumference around it. Okay, we all know or should know that a circle is 360 degrees, right? So what is the measure in degrees of an angle that is equivalent to 1/360 of a circle? So let me kind of do this a little neater for a second. So if there was a sliver taken out of here, if that's the center, and there was a sliver in here, what's this angle here? Okay, we can call it angle A. Okay, if it's 1/360th of a circle, okay, well, this turns out to just be a multiplication problem. If the whole circle is 360 degrees, and we're looking at 1/360th of it, okay, that's just equal to 360 over 360, and that's equal to 1. Okay, and think about it logically too. If the whole circle is 360 degrees, what's 1/360th of it? It's got to be 1, because this, if you add 1/360 times, you're going to get all the 360 pieces, right? If we actually took the circle and just keep splitting it up so that there was 360 little sections in here, right? Okay, each little piece in here will be a 360th. Well, that's what the question's asking us. All right, so we can solve this visually, we can solve it geometrically, we just can solve it logically. All right, so that's what they're asking here. So again, I'm Greg from Greg's Tutoring at NYC. I hope you guys are getting something out of this. If you're finding these problems easy, that's cool. That's great. Just consider this a review. And if you find this easy, I'm going to do a grade 5 one now. Okay, so as we're incrementing along, and that's the way it should be. If you're on grade 4, you should be getting all the grade 4 questions right, and all the grade 3 questions right, and some of the grade 5 questions right. Okay, when we go to grade 5, you should be getting all the grade 3 right, all the grade 4 right, all the grade 5 right, and some of the grade 6 right. Okay, and as we go along to that, so nobody's perfect. So if you're in grade 5, you should be getting all the grade 3 and all the grade 4 right. I said before all the grade 5 right too, but enough of them right. A lot of them right you should be getting. Okay, and then even some of the grade 6 right. All right. So if you guys have questions, please email me, GregsTutoringNYC@gmail.com. If anybody's interested in tutoring, let's do this. I tutor in math and English mainly, but I also tutor other subjects as well. There's no harm in asking me. Send me an email, GregsTutoringNYC@gmail.com. And on that note, let me go back to the YouTube here. I'm going to peace out, guys, and hope you guys have a nice day. And I'm going to do a grade 5 at some point as well. Yes.